Hey everyone. So I'm going to teach you how to model real life right now, as long as the real life situation is linear. Okay, we'll just keep it to linear. So let me give you a scenario. Let's say that you have a movie theater. Okay, and let's say that there are 120 seats in the movie theater. Right. So you have 120 seats, and then let's say, and this is not realistic necessarily, but keeping it easy. Let's say that every minute 5 people come in. Okay, fill up a seat. So um, every minute, every minute, 5 people sit down. And then the question can be, can you model this using the math that we have learned? So obviously you could go find a theater and run the experiment there and just let 5 of your friends come in every minute or whatever. But you can also just do it using a whiteboard and not doing anything else than you whiteboard in your brain. So that's what I was trying to push you to. Look, the very first thing I think to do, this is not the most powerful function form, but it is like the easiest to get a handle on things. Table. Use a table. So if I do this, then I don't know if you can tell what my x and my y are. Sometimes kids can tell. I'll usually let you know if it's confusing to you. Right here, I'm interested in how many seats are left as time passes. So my x-axis is going to be the time in minutes. And then this is the number of seats left. Okay? So I don't know if you folks can do this, but it'd be good practice. Freeze the video and see if you can guess what I'm about to write in the y column. So here's what I got. At 0 minutes, right when you open the doors, there's 120 seats left, right? No one's sat down yet. And then 1 minute later, there have been 5 people, so there's only 115 seats left. A minute after that, some more people have sat down, so I'm only at 110, and then 105, right? And you can keep going, blah, 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 right? Good. So that, I think, helps you establish a couple of things. One is it helps you say, like, okay, this is the situation. I have a better grasp on it. And then more importantly, I can look at this and be like, hey, you know what this thing is? It's linear. You're in our case, subtracting the same number every time. As your x's are going up by ones, you can go ahead and graph it. It's going to be a line. And once I know that, then I know the really powerful thing, which is I know its algebraic rule is going to look like y equals mx plus b, okay? And then in this scenario here, if you just give people, well, actually, let me hold on to that. Let's just figure out what the m and the b are first, okay? Can you all tell that the b is fairly easy? It's the y-intercept, and when you look at this, Shazam, right? That's the y-intercept. So I already know I've got 120 here for my y-intercepts. If you need the m, that's the slope. So you can just do a change in y. So let's do 105 minus 110. You can pick any 2 points you want. And then 3 minus 2. I'm assuming you know how to find slope. If that didn't make sense to you, I just did our old friend. This is my y2 minus y1 and x2 minus x1, okay? Anyway, it looks to me like 105 minus 110, that's seats. And this is 3 minus 2 minutes, right? I'm just going to let you know, I want you to see what the units are going to be. This is -5 seats. This is 3 minus 1 minute. So that's going to equal -5, and then it's seats per minute. -5 seats per minute, okay? So I don't usually put the units when I plug in for m here. So I will usually just write this, -5x, okay? Now, if you just give them this, like if you give somebody this thing, they're going to be like, whoa, 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 what's this about? Yeah, I don't even know what this means. So it's good to tell them what your x and your y are, which is easy. You already have a table that shows you. Your x column here is for time in minutes, so your x variable is the same thing, time in minutes. And your y column here is number of seats left, so your y variable here will be number of seats left. They won't change. And now somebody has a fighting chance of understanding what your model means, okay? So there's like maybe 4 questions that can be asked about this. One is, what's the y-intercept? We already know, it's 120, right? It means right at time 0, you got 120 seats left. Another one you can ask is, hey, what's your rate of change mean? Well, rate of change just is the same as slope if you have your toolkit handy, okay? We made that clear in the toolkit. So if I'm looking for my rate of change, I'm just looking for the slope, and that is this guy right there. So rate of change would be -5, and then I'll put the units on it. It's -5 seats per minute. And then we'll often ask you for an interpretation of that, so ROC, interpretation. And this is that cute little rhyme that we do. Understanding the rate of change is easy as apple pie. As x goes up by 1 is what the y is changing by. Hey. So let's try to put that here to this situation. So as x goes up by 1, but my x here is time. So as time goes up by 1 minute, the rate of change, sorry, I'll move this. The rate of change is what our y is changing by. So as time goes up by 1 minute, the y, so the number of seats left, oops. Can you tell it goes down by 5 because we're going down negative each time? Goes down by 5. As time goes up by every 1 minute, the number of seats left go down by 5, okay? So those are 2 questions we can ask you about linear models once you have, oh, I didn't really say that, but when they ask you for a model of the situation, yeah, you can go do an actual theater and that kind of thing, and that would be a model. It actually would be the real thing. But this also is a model, okay? And all it takes is a whiteboard and a marker, and then you can go and simulate anything you want. And it's just so much cheaper and faster if you know math. So we have our model, and now I want to know, once you have the rate of change, once you have the y-intercept, can you use the model? So let me tell you a kind of question I could ask. I could say, hey, how many seats are left after 14 minutes? So you could do it the slow way. You could say, hey, I got a table started. You want the number of seats left after 14 minutes? No problem, buddy. Here I go. After 4 minutes, I'll have 100. After 5 minutes, I'll have 95. And you could just keep going all the way down. But I want you to know a faster, more powerful way. Oops, should I show all that? Yeah, I did. And that is to use the rule. Do you agree with this? If you don't know how to use the rule, at least you agree with this, that we're interested in minute, wait, did I say 13 or 14? Let's just say I said 13, I can't remember. So do you agree that I'm interested in minute 13, how many seats there are? Well, if your x is 13 over here and you're looking for a y, the rule will act the same way. In other words, you can put a 13 in for the x, and that rule will tell you what the y is. So let's just do that. Y equals -5, and then times that 13 plus 120. Just like that. So I think if you do the arithmetic here, this is -65 plus 120. And so if you do that, I think you get what, 55? So the number of seats left after 13 minutes is going to be 55. 55 seats. And you see how you use the rule there? Like in 3 lines, you're able to get it. Whereas, you have to take it down quite a ways until you get to minute 13, okay? So it's good to be able to use the rule. And if I had said, oh, what about after 17 minutes? No problem. instead of doing the table, just put a 17 in for x, and that'll do the arithmetic, and you'll get your y. Okay, last kind of question I can ask is, let's say I want to know how long it takes until everything is full. So you could go down. You could do your 100, 95, and go all the way down until you get to 0, and then just figure out when does that happen. But here's the thing that I'm going to tell you. Don't you agree that y is 0 here, and we're looking for the x? So the function, the algebraic rule, will behave the same way. Your y is 0, so put a 0 in there for y. Bam. Like that. And then you have an equation, but you can solve it. If you know algebra, you know how to solve this thing. Take 120 away from both sides. Bam, bam. You get negative 120 equals negative 5x. Oh, sorry. And then divide both sides by negative 5. Getting sort of low on the board here. Can you still see that? Yeah, you barely can. Okay. And then we'll end up with x equals, I think that's going to be 24. And that is in minutes, right? 24 minutes, because my x is in 24 minutes. So, if I can squeeze the minutes in there, sorry, that's a little sloppy. 24 minutes. All right? One other thing really quickly, I can also say, hey, this is a great model you have here, la, la, la. When does it stop making sense with real life? It's easiest, I think, to see that using a graph. So we have the table form, we have the rule form, we haven't looked at the graph form, so I'll just very, very quickly sketch it. Bam, bam. My x has always been time here in minutes. My y has been number of seats left. And we started with 120 seats right at time 0, and then we just go down, down, down. And this is a line, so like it's just going to keep going back and forth. So when does this thing not make sense? When does this rule like not really replicate real life anymore? Well, do you agree we can't really have negative time here? Like this rule says, oh, when you have negative 3 minutes, you're going to have more than 120 seats left. That doesn't make sense with a theater, right? So forget any part of this line. Don't believe anything it says. And then you may have already realized this. Once you get to where, I'm sorry, this is 24. Once you get to 24 minutes and you got every seat taken, what the model says is that if you keep going to 25 minutes, 26 minutes, you'll have negative seats left, right? And does that make any sense? Can you have negative seats left in a theater? No, right? So you can't really believe any of this stuff here. But this stuff in this quadrant, me thumbs up. All right? So you can make a rule. You can identify and interpret the y-intercept and the rate of change. And then the two kinds of questions are, if I give you x, can you give me y? And if I give you y, can you give me x? And then can you just tell when the rule starts falling apart and doesn't model real life anymore? Okay? So that's how you do those problems. I hope that helps.